Hello, I'm Jason with ScienceandMath.com, and today we're going to do the incredible floating egg, which is going to show you how you can actually get an egg to float in water, and you'll see in a second why that's a little bit unusual. So let's just go ahead and get started. What you need for this experiment is 2 glasses of water that you can see through, and you fill the glasses with water. Leave yourself a little space at the top, of air there. And you'll need 2 eggs. These are not boiled eggs. These are not peeled eggs. These are just regular eggs out of the refrigerator, uncooked, unprocessed. And you'll need some table salt. That's what this is here, and a spoon. So we probably won't use this much table salt, but this is just what I had laying around. So grab some table salt. So what we're going to do is take this out of here, and we'll go ahead and take the eggs out of here, and we will go ahead and do something like this so that we can see both glasses in all of their glory. So basically what we want to do is figure out, number one, does an egg float in water or not? And the easiest way to do that is fill a glass with water and go ahead and give it a shot. So let's go ahead and take this first egg, and let's gently, we don't want to splash it, but we gently want to put it in there. And you can see the egg sinks pretty rapidly. So the egg sinks to the bottom, and what that means is that, everybody's gone swimming, right? So you know that when you jump into a swimming pool, you have a kind of a force kind of trying to keep you floating. It's called the buoyant force, right? But you know that you also sink to the bottom if you, don't do anything. If you just jump into a pool and just play around, and you'll eventually sink to the bottom. So you know that you have weight, and you know that you have some kind of force that the water is trying to keep you floating. But if you don't do anything, you don't kind of do anything special, if you don't have a life jacket on, most people are still going to sink to the bottom, even though they kind of weigh less, so to speak. It's not really that you weigh less, it's just that you have a certain weight, and the water is pushing up on you with an upward force that we call the buoyant force. Same thing is happening with this egg. It has a certain weight. It's trying to go down because of gravity. The water is exerting an upward force called the buoyant force. It just so happens here that the egg weighs more than that buoyant force is pushing up, so it sinks, right? That's basically what's happening. So we all know that if we take the second egg and put it in the second glass of water, the exact same thing is going to happen. But let's change things just a little bit, and let's go ahead and put some salt in the second glass of water, and we'll see what happens. So let's go ahead and let's do 1 tablespoon roughly, 2 tablespoons, 3, 4. You need quite a bit of salt in there. You need it to be pretty salty. Let's try 5 tablespoons. You could do a little bit at a time if you wanted to, just to see what happens. And all of this salt is probably not going to dissolve. It's just a matter of getting enough of it dissolve to help to actually make this work. So what's going to happen is we're going to stir this for a while, we're going to agitate it, and after a while, you see how it kind of clouded up? After a while, it's going to turn more or less clear again, maybe not quite this clear, but it's going to turn pretty clear. And this salt, we pour it in crystals, but the salt's going to dissolve. Now, while I'm stirring this, let me explain to you. When you put salt, or sugar for that matter, into water, it doesn't disappear. We see it dissolve, and a lot of people think it just disappears. Well, the salt doesn't actually disappear. It just breaks down into microscopic little particles, microscopic little pieces, and they fit in between the water molecules. So you can't see them anymore, but they're there, right? That's what we call dissolving. So let me ask you a question. This glass of water here that I'm stirring up with salt, if I had exactly the same amount of water in this glass and in this glass, if I had the same amount of water in both glasses, but then I added salt to one of them, if I could somehow weigh on a scale how much force of gravity was acting on this amount of water and on this amount of water, if I had the same amount of water to begin with, but I put salt in one of the glasses, which one do you think would weigh more if I could somehow weigh everything? Well, the answer is this guy would weigh more, because the salt, even though it's starting to disappear here, it hasn't really disappeared. Everybody agrees that salt has weight, right? So if I put the salt into this cup, it's still going to be in the cup. It just sort of disappears from your view because it goes microscopic and it goes and fits between the water molecules. So that's something that we're going to come back and use in a few minutes after we actually do this here. So let me go and take the spoon out, and we'll give it just a few minutes to kind of clear up. So we let just a few minutes go by. I didn't add any more salt to this water. We just let it sit there, and you can already see that it's much, much clearer than it was right after we put the salt in. That just comes about because we were stirring it a lot, so there were some air bubbles in there, plus there was a lot of salt in there that's been dissolving. So let's go and give it a shot. It may float, it may not float, but let's see where we stand. So let's go ahead and gently put this in there and see what happens. We'll let it go, and you can see that that egg is actually floating now. And not only is it floating, it is floating all the way to the surface, clearly buoyant. If you push down on this egg and push it underwater and let go, it's going to float just as if it had like a little life jacket. Now these are not trick eggs. These are not, really any different size. I mean, they're pretty much the same size, more or less, same weight, more or less. But somehow adding this salt to this glass of water makes this egg float when this one doesn't float. And the secret comes into understanding why ships float and why, why we have that buoyant force when we jump into the water. So let me explain what we have here. So in the first cup, we have regular old water. And we said that anytime you put something in water, a force kind of comes from the water and tries to push you up. Everyone knows this from swimming, right? Now, how do you calculate that force? It turns out that that force is equal to the amount of water displaced by this egg, by the weight of the water displaced. So in other words, when I push this underwater, notice how the liquid level goes up. It gets pushed up slightly when I push this egg underwater. That's because the egg is actually pushing that water out of the way. So however big this egg is, however large it is, it's going to push that much water out of its way when it goes into the water, right? So what science tells us is that the amount of force that pushes up on this egg while it's in the water is equal to the weight of the water that was pushed out of the way. So the egg is this big around, we put the egg underwater, that volume, that much water is pushed out of the way. However much that water weighs that was pushed out of the way, that's how much force is acting up on this egg. But this egg has weight, so it's trying to go down. The water is pushing up with a buoyant force, but it turns out the weight is actually bigger than that buoyant force, so the egg still sinks. Notice whenever it does drop, it drops very gently. That's because there's an upward force acting on it inside the water. So don't forget, the amount of force pushing up is equal to the weight of the water that was pushed out of the way by that egg. Now in this situation, the only thing we changed is we added salt to the water. And we said that when we add salt to water, it looks like it's disappeared, but it hasn't disappeared. This water actually weighs more than this water. If I had 2 glasses of water, same level, same size glass, and I just put salt in one of the glasses of water, then that water in that glass is going to actually weigh more for the same amount because I put mass in there, I put stuff in there, I put salt in there, right? So what this means is that this egg, when I put this egg in here, this water actually weighs more. So when I push this egg in there, this egg again pushes water away, and the force acting on this egg is equal to the weight of the water that was displaced and pushed out of the way. But since this water weighs more, then when the egg pushes that water out of the way, the buoyant force is greater because the water weighs more. Remember, we said the buoyant force, the upward force, is equal to the weight of the water pushed out of the way. This water weighs more, so when the egg pushes it out of the way, it gets more of a buoyant force. That's why this egg floats. That's why this egg sinks, right? And that's basically how ships float, by the way. You ever wonder why enormous cruise ships that are bigger than a football field can actually float, even though they're made of metal? That's because they're made very wide, right? So when you put them in the water, they push an enormous amount of water out of the way. And the weight of that water, right, is going to, that's pushed out of the way, is going to be translated into a force. The weight of the water is equal to the force upward on the ship. So if you can make a ship, doesn't matter if it's made of steel or not, if you can push enough water out of the way, then you'll get enough of an upward force to float the ship. And that's what's happening here. It also means, for those of you who like to go swimming in the ocean, that even though you may not have noticed, if you go swimming in the saltwater ocean, you actually are more buoyant. You float a little bit easier than you do if you're going into a freshwater pond or a swimming pool. And that's because the ocean water, for every volume of it, every size, every cupful of ocean water, so to speak, is going to actually weigh a little bit more than a cupful of fresh water because of all that salt in the ocean water. And so there's a little bit extra force that's helping you to move up. So very simple experiment. Make sure you go and do it because it's actually quite interesting to sort of figure out how it works. Now the exact amount of salt to put in there I can't really tell you because it's going to depend on how much water you have, how big your cup is, and so on. So put a few tablespoons of it in there, and you notice that we really have to stir it to get it to dissolve. So go ahead and do that. Let it settle, and then drop it. Now, if we dropped our egg in there, I didn't know if it was going to float or not. It might have it might have gradually started to sink, in which case I would just add a little bit more salt and do it again. So you might have to kind of balance the amount of salt that you put in there to do the experiment, but as you can see, it's pretty bulletproof. This egg definitely is floating, and the main thing that we learn from this experiment is what is a buoyant force, and that is the amount of water pushed out of the way by the object. The weight of that water is equal to the force pushing up. So if you have heavier water, then you push the same amount of water out of the way, it's going to give you more of a lifting force, and that's called the buoyant force. So I'm Jason with ScienceandMath.com. I hope you've enjoyed this. Go do it yourself. Make sure you understand how things float, how things sink, and how even though it looks like we have two identical glasses of water, in fact, this one has salt dissolved, so it actually gives you more of a buoyant force.